I'm going to start by talking to you about why hydrogen. I'm going to say something about hydrogen, a perfect fuel. Talk to you about the rollout of hydrogen infrastructure around the world, and then particularly major projects in the UK. And then at the end, just give you a summary of some of the market dynamics. So what I'd like to do in talking about why hydrogen is talk to you about battery electric vehicles, petrol hybrid electric vehicles, and fuel cell electric vehicles. Here's 3 low-emission drivetrains. The first one that you see is a battery electric vehicle drivetrain. That's a car that you plug in and charge up a battery, and it has a rather large battery. It takes a long time to charge, and it only goes around 80 to 100 miles. The second drivetrain is a very interesting development. It's a petrol parallel hybrid electric vehicle where you actually, rather than having to use a new infrastructure, which is a charging infrastructure, you use the existing infrastructure. You fill the vehicle with petrol. A petrol engine then charges the battery. But interestingly, what you're doing in selling that vehicle is rolling out an electric drivetrain. And in fact, if you take the Prius, for instance, which is a very good example, many millions have been sold around the world. Actually, all you have to do to turn that into a hydrogen electric vehicle is replace that petrol engine with a fuel cell. Then what you're doing is refueling that vehicle with hydrogen rather than petrol. And that gives you a zero-emission vehicle with a drivetrain that's already been developed. What you can see here is a comparison of speed, of range, and of charging or refueling time. And you can see that for all of those vehicles, they have a comparable speed, and it's not dissimilar from an internal combustion engine. In terms of range, actually the battery electric vehicle has a lower range, but the fuel cell vehicle is comparable to an internal combustion engine. And in fact, most fuel cell vehicles could do 400 miles on a single charge of hydrogen, which you can get in 3 minutes, which is a very similar experience to refueling with petrol. It takes longer to recharge an electric vehicle, a number of hours, maybe 5 to 6 hours. You can use rapid recharging. You end up with a more expensive infrastructure, but you can get that down to around 30 minutes. So what you see here is range versus carbon footprint. And the hatched area in the low right-hand side is where range, long range, overlaps with low carbon footprint. And you can see right in that range is a fuel cell electric vehicle. People always worry about efficiency. Efficiency is a bit of a misnomer. It actually depends when you're exporting the energy from a particular energy grid. But here is the well-to-wheel efficiency of all of those vehicles. What I've done is I've gone tank to wheel and infrastructure to tank. Because what happens is people look at the vehicle itself and they say, well, it's more efficient to charge a battery. Actually, if you look at the whole well-to-wheel analysis, there's a higher efficiency for a fuel cell vehicle. How will these vehicles play together? Well, actually, we'll have a portfolio of vehicles in the future, I'm sure. What we'll have is small, low-range vehicles that will be plug-in electric vehicles for cities, and for very large, long-range vehicles, fuel cell vehicles. So this analysis comes from Toyota. So let me talk about hydrogen as a perfect fuel. Talk about hydrogen that's made from renewable power that can be made on site. So what's the challenge here? Well, actually, we're planting up an infrastructure of renewable power, and it needs energy storage. And actually, energy storage is a pretty elusive thing and has been for a long time in the power industry. Actually, it's very difficult to store power for long periods of time, but it's very easy to store hydrogen. And you can make hydrogen with a 70% energy efficiency directly from renewable power and store it for as long as you want. And that's why I talk about a perfect fuel, because it has absolutely zero carbon footprint. The way you manage that then, this is equipment that we're putting down on Eco Island. That's 1/4 of a megawatt of load that stores power for 2.5 days. It's completely modular, and you can build it in terms of the power rating or the energy rating. The point about hydrogen is that if you want to store the power for longer periods of time, you just make the tanks bigger. With other technologies, you have to buy more and more of the expensive part. The unit would be demand-side managed by power companies, in our case, Scottish and Southern Energy, and if it's used to balance against renewable power, it has a zero carbon footprint. Also, we make it on site, so there's no carbon footprint in its transportation. And of course, with a fuel cell vehicle, the only emissions are hot water. So we call it a 000 fuel. The other very important thing is that you can make hydrogen for less than £5 a kilogram. That's important because that means the fuel is lower cost than petrol or diesel. And it's made on site, and it's zero carbon footprint. Okay, so let's talk about the rollout of hydrogen infrastructure across Europe particularly, and also the vehicles. So there were accords signed in Germany and the US to roll out hydrogen vehicles with a target date of 2015. And actually that's a commitment from all of the OEMs to be rolling out tens of thousands of production vehicles each in 2015. Actually, Mercedes-Daimler are going a year early in 2014, and Hyundai, who are here today, are going early in 2013, which is next year. And in fact, now you can buy a Hyundai vehicle. There's a vehicle outside that you can even test drive. What do you have to do if you want to roll out hydrogen vehicles? Well, actually, what you have to do is coordinate the rollout of the vehicles and the infrastructure. And around the world, we call these hydrogen mobility programs. The first one was in Germany in 2009. The South Koreans started buying fuel cell and hydrogen equipment en masse, actually, from 2009, and are making incredible progress in Korea. The Japanese government announced the rollout of hydrogen vehicles. It was actually a joint press release between Honda, Nissan, Toyota and the Japanese government, and they're building 200 refueling stations. In the UK, we announced UK H2 mobility with the UK government at the end of 2011, and the Danes and the French have just shown their hand in terms of mobility programs, both of which are going to use 100% electrolysis because they need the energy storage. So the German program is very significant. Here's a map of the rollout. There are many existing hydrogen refueling stations in Germany, another 50 announced just a couple of weeks ago, and more coming all of the time. We were delighted to be the refueling partner at Hanover. Actually, we got our first permit to operate in Germany, got our expert report from TÜV Süd, passed all of the qualifications, and made hydrogen on site at Hanover and refueled the fuel cell vehicles. UK H2 mobility was actually started at the end of 2011. The announcement was January 2012. Here are the partners. A very significant breakthrough in the UK. We got an MOU signed by DEC, BIS and the Department of Transport. So 3 government departments with a consortium with these industrial companies. The infrastructure then is BOC Linde, Air Products, Air Liquide, and ITM Power, and there are many car companies involved, and one utility, Scottish and Southern Energy. So I think a great breakthrough for hydrogen mobility in the UK. Okay, so let me tell you about 2 more developments in the UK, 2 projects that we've been involved in, Marks and Spencer's and also Eco Island. So we're interested in individual vehicle refueling, and we have a significant project with Boeing in the area of aircraft. Depot refueling, we work with Marks and Spencer's on refueling forklift trucks for warehouses. Island refueling, and we're working on Eco Island with a whole range of partners, which I'll show you in a moment, and also with UK H2 Mobility on infrastructure rollout. Each of those has a different size of refueling unit, but the refueling units are completely scalable. And all of those products are available for sale today. Forklift trucks is an early adoption market. I won't dwell on forklifts, just to say that as early adoption, what I mean is Walmart, Coca-Cola and FedEx have adopted hydrogen in their warehouses for their forklift trucks. It's a direct replacement for the battery. We work with Marks and Spencers, and we talk with 6 of the 10 largest retailers in the UK about converting their battery forklifts to hydrogen. And the win here is performance. Actually, you can refuel a forklift truck in 90 seconds rather than recharging it in 6 hours. And it will do an 18-hour shift. If you're interested in this, there is a video on our YouTube channel. When I say a direct replacement, it really is a direct replacement. Here's the fuel cell that we are the distributor for. This is made in Texas. It is a direct replacement from the battery. You see the fuel cell on the left and the battery on the right. You slot it into the forklift truck, and you can refuel it in 90 seconds. It takes about an hour to do that changeover. Okay, Eco Island. Eco Island is the Isle of Wight, and the Isle of Wight is planting up with renewable power. Its aim is to be completely self-sufficient in energy, not just electricity, but energy, and be a net exporter to the mainland. To do that, you need energy storage, and you need a smart grid. And we're doing the hydrogen energy storage and hydrogen vehicle refueling system. We work with SSE, who are planting up the renewables, Toshiba, who do the smart grid controls, IBM, who are doing our user interface, Cable and Wireless are doing the data communications between us and the refueler, and between the refueler and the vehicles. And we work with Toyota and Hyundai on the vehicles. And there'll be fuel cell vehicles, hydrogen internal combustion vehicles, and also marine vehicles. So let me just finish with some market dynamics, a very simple market dynamics of what the drivers are for the adoption of hydrogen worldwide. So 3 things that are very important. First is that fossil fuels get more and more difficult. So there's a fantastic article, The End of the Oil Age, in The Economist, and another one in National Geographic called The End of Cheap Oil. I mean, actually, oil just gets more and more difficult. If you invest in oil exploration companies, you'll be used to wells being spudded, channel tests being announced, and then those explorations being sealed off. Because very, very much less oil is now being found, and condensate. At the same time, the world's planting up with renewable power that needs energy storage. And actually, you can store the energy as hydrogen and replace the oil that isn't there anymore with that hydrogen made from renewables. And the third dynamic is the sale of electric vehicles, which peaked a couple of years ago and is now declining because of some of the issues to do with recharging time and range. Actually, they're the 2 problems that are solved with a hydrogen electric vehicle. You get the fuel in 3 minutes, and you can travel 400 miles. So here's just a small observation at the end. The world has a serious problem. It has to decarbonise energy, and energy is the largest market in the world. Actually, that problem, viewed dialectically, is a huge opportunity for the UK. There's more capital equipment being bought in this market now than there has ever been before. It's the largest capital spend in history. And we should be manufacturing and selling the equipment in the UK that's being bought worldwide. What you can see outside today is the Hyundai fuel cell vehicle and a mobile refueling unit. Both of those are real offerings. They're actually for sale. And I'd recommend to you that you get in the Hyundai vehicle and drive it. It's a fantastic vehicle. And if you drive it, if somebody says to you tomorrow, hydrogen vehicles are years away. You can say, no, they're not. I drove one yesterday. Thanks very much.